Go crazy, Joel.
Go crazy. Okay. Well, welcome to tonight's class on C++. For those who don't know, my name is Joel Byers. I'm the software team lead over at the Lunabotics project. So some of you are currently taking a class over C. For those of you that are in that situation, you're in a not actually a bad place because C++ is very similar to C. C++ came directly from C to just improve the language and make it overall better. A lot of the things that you already know, like quite literally, are the same in C++. So you all should have code blocks pulled up. You guys can see it, right? You can see my code blocks. So if you want to type some code, I'll be making just simple programs. You can save this so you have examples. Just if you want to just take notes, or you just want to watch and try to remember it yourself, it's completely up to you how you take notes. Let's see. My notes are over here on the TV because it's the only second monitor I have. So if you see me looking over here, that's why. Okay, let's go ahead and make a new file. You just go over here and click on empty file. It'll just give you literally just a blank text document. We have to actually eventually declare it as a C++ file, but for starters, I'm just going to put something random in here just so we actually have something to save. Okay. Oops. Okay, let's actually, okay. So yeah, so to actually make this a C++ file, let's go up here and say File, Save As. And we're going to name this, I'm going to call it CPP class. And and it's defaulted to accepting C and C++ file extensions. Let's make it C++. You simply just come in here and say .cpp. Simple as that. You hit save, and now we're getting some nice syntax highlighting. So the first thing I'm going to show you guys is basically the bare minimal to get a program up and running. I'm going to just go over, I'm just going to type some stuff. I'll explain some of it. I'm going to leave parts of it though, just because I'll explain it later and it'll make a lot more sense if I explain it at that point in time than try to just give you everything right off the bat. So the first thing, if you're typing along, you can put this include IO stream. Those of you taking the C class will recognize the !include. This literally just tells your C++ compiler what libraries are being used in the program you're writing. When I say a library, I mean like somebody else's code that they've already written. That's a library. So go ahead and say !include IO stream. The IO stream, that's for printing stuff out to the screen and reading stuff in as well. So it's !include. And you're also going to type using namespace standard, semicolon. Using namespace standard, I will explain that much later, but for now you're going to need it. And here's our main function. And if I'm not mistaken, this is identical to C, but just goes int main, parentheses, bracket, bracket, and return 0. So that's it. That is everything that you need to run a C, or to have like a very basic C++ program. I need to move my task thing here. Oops. There we go. Just lost. There we go. All right. So in code blocks, if you want to compile your code, compile just means to tell the computer to convert to something the computer can actually read and run it. Just come over here to this little gear in the play button. Click on that, and it'll build and run. You'll see what it's outputting down here, and this just means that it ran. There's nothing actually happening because we didn't give anything to do. But just to prove to you guys, this is literally all you need. Everything else from here is just giving it functionality. see here. Oops, I moved that. All right. So this is your main right here. What your main is it's the part of the code that is going to basically run when the program starts. So your runtime engine, which is what's going to run your code when you is going to look for the main. It's going to do is it's going to run this from top to bottom. Basically, anything between this curly brace and this return is going to run. Okay. Just literally as a statement is hit, it's going to execute it until it's done. So let's go ahead and give it something to do. First thing I'm going to show you guys is just how to put simple output to the screen. And that's why we have this pound include IO string. If you don't have that, you'll need to put that in. So in C, you have something called printf and some really weird syntax and stuff. In C++, we use something called cout, okay? And the syntax for this is you say cout, and then you're going to use what's called an extraction operator, which is literally just 2 less than signs. So cout, 2 less than signs, and then after the 2 less than signs is what you want to print. So I'm going to just put a simple string here, and I'm just going to say hello there. And of course, you need a semicolon. For those of you new to this, semicolons are used to end statements. So anytime you have a statement that is going to run, you need a semicolon. So now that we have that, we can just go ahead and recompile and rerun it. And we'll just look at that. There's our text. So you notice that was on the same line, which wouldn't have closed that. If you want to return, as in like, so you want it to print and then you want it to go down to the next line, C++ has this handy thing called endl. You add that, and it will go ahead and just return. Does everything make sense up to this point? Anybody have any questions?
Joel, is Zoom set up to share just your code blocks? Because your terminal window like pops up and then immediately disappears.
Ah, it does. Okay, let me fix that real quick. I didn't think of that. So I will stop my share. Oh, where's my, here we go. And I'll just share screen 1. Okay, so now if I go ahead and do this, you'll actually see my output. Perfect, there we go.
There we go.
Right, you can see that? All right. So yeah, nobody had any questions? If at any point you are completely lost, please stop me, because the moment that you get lost, nothing else is going to make sense. That's just the nature of the beast. You're learning a completely different language, different way of thinking about things. Okay.
Hold up, Joel, just a sec.
Yep.
Every time I try doing this. Joel, do you have any idea why a terminal window would not be popping up when they hit the build and run button?
Boy, that's a new one. I've never heard of that problem, I guess. Um, there's not
Not.
just like a different place it's going to put output, is there?
Oh, okay. Um, okay, so it's a compiler error. It can't find his compiler. How would we fix the
Okay.
code blocks?
There should be I think under settings, there's like environment, and then there should be a compiler place.
Oh, there
I
totally is.
think. Yeah.
Go back.
Yeah,
Go
go
back
ahead.
to settings.
For those of you, just while we're waiting, just one thing I want to point out. So what we're doing here with the cout with this extraction operator is we're literally just like stringing together different statements. So after the cout, what it's doing is it's taking this hello there and it's merging it with the end line.
11 through.
And then that's why you get the hello there and the return with the same statement. So if I was going to come in here and I wanted to add something else, I would just put another extraction operator, put another string. I think that's how you spell Kenobi.
Joel, can you check what your compiler is quick?
My compiler is. How did you get to your compiler?
Just settings compiler. There will be one thing checked, maybe.
Yep, I got C++.
14?
Yep.
So try to set it to that. And then is anyone else here on 20.03, or is everyone on version 17.12? You're on 20.3? Okay. What is your, so hit settings quick up top. And then compiler. There we go. Okay. If you scroll through there, see if anything's checked. No, nothing's checked. Are you on 20 either? Okay. Oh, okay. That's weird. I don't know why. Wouldn't be finding it for you. You can do this actually. Joel, are you working with like header files at all today?
No, I wasn't going to.
Okay, sweet. So I can have him use a like a compiler online, like a web one that'll just test code.
Yeah, if you can find one, go right ahead.
Yeah, I've got one. So if you just Google.
All right, I'm gonna move on to the next thing then. So
go ahead.
We can keep it moving. But yeah, so you saw there, it actually wasn't a very good output because it just pushed the two together with no space. But that's how you string together stuff with the cout. All right. So the next thing we're going to go ahead and talk about is variables. So in any programming language, really, you're going to use things called variables. And what a variable is it's just a place for the computer to hold information. There's no other simpler way to say it than that. Hold information. So there's really three different types, basic types of information that your computer can hold, and that's your C++ code is going to be able to specify. And that is numbers. We got numbers, we got letters, and we've got just a simple true and false. Those are the three types of basic, they're called data types. I'm going to use that term right now, data types. So for numbers, there are three basic data types. There is the int, there is the float, and there is the double. An int is just a whole number, while a float and a double, those are both decimal values. For this course, we're going to be using double, but you will see float. And for all intents and purposes at this point, you can just think of them as a decimal value. All right. So when you make a variable, you're going to give it a name. And so every time that you're going to use that variable in your code, you're going to call it by its name. So here is this basic syntax for that. Oh, I thought I mentioned these double lines here. It's called a comment. Just basically means the compiler isn't going to use any of this when it makes anything. So it's just going to skip it, but that's just a little note. But anyway, so the syntax for making a variable is you're going to first say what the type is. So let's go ahead and make an int. You highlighted it because it knows what an int is. We're going to give it a name, and I'm going to call this my var, my variable. And then you are good to go. Now you can reference this my var, give it values. The variable can change, as in the number that's in it can change. And that's how you're going to ultimately basically do everything in your code. You're going to have to be storing in variables so you can actually mess with it and reference it later. So right now, this variable is uninitialized. It doesn't actually have a value. So it's just empty. If you tried to reference this, you'd get a bunch of garbage because the compiler doesn't have anything good in there. Not the compiler, but the program doesn't. So in order to initialize it, all you're simply going to do is just say equals, and you're going to give it a value. And I'm going to set it equal to 0. Okay, and then we're going, if you want to reference it, and I want to see what's inside of my var, I'm just going to, right here, I'm just going to print to the screen. So I'm going to say my var. And then what this is going to do is it's going to say, okay, you want to be looking for a variable called my var. It's going to go over here and say, I found it. What's in it? A 0. So if I go ahead and run this, we should say, hello there, 0. Does that make sense to everyone? Any questions at this point? All right, sounds good. So if I go over here and I just change this to a double, print it again, it's going to be the same thing because it's just a whole value. Doubles can hold whole values. But if I want to come in here and say 0.9, I can do that. And it'll go ahead and print the 0.9. If I tried to make this an int and give it a 0.9, it says 0 because it can't hold decimal values. Some compilers will just crash it, but this won't. I'm going to leave it as an int, leave it to 0. So for letters, there are, I'm going to make this a better comment. So for letters, there are 2 basic types. There is the char, which is just a single character. And then there is the string, which is a bunch of characters. This right here, this is a string. But if we're going to use a string, that's not actually a basic class, or that's not a basic data type. So what we're going to have to do is we're going to have to come up here, say pound include string. And then we can use a string. So you can go ahead and add that because we'll probably be using string data types for the remainder of this class. Okay, so yeah, just like your numbers, if you're going to make a string type, you just go over here and you give it. First thing you do is you put the type, give it a name. I'm going to give it my string. And then if you're defining a string, what you're going to use is the double quotes. Okay, so every time you see double quotes, that's a string. If you're going to define a string, you have to use the double quotes. If you don't use the double quotes, I'll show you that later, you won't get anything good coming out. So this is my string. And of course, semicolon because it's a statement. And now if I go in here and reference my string, might be a capital what?
Include is spelled wrong.
Oh, thank you. You think by now I'd be a half decent typer. Yep. So you go ahead and you see that output. So the third type of data was just the simple true and false. And what we call that is a Boolean. actually, I think it's just bool in C++, but Boolean is what it's actually called. And all that is it literally can only hold true and false. And this is very useful in programming because there's a lot of times where you only want it to be able to have two states. Rick, do we have to do a pound include for bool in C++?
I don't think so, no.
I think it's inherited. Yep, okay. So if we're gonna make a bool, just say bool. I'm just gonna say TF for true false. And if you're going to assign a value, you're going to actually either type out entirely true or false. Now, I don't know if this is going to print the word true or if it's going to print a 1 or a 0. It's probably one of the two. Yep. Okay. So when the compiler actually goes to compile it, it's not going to use true and false. It's going to use 0 and 1. So if you try to print it, it's going to give you a 1 or a 0. But when you're actually thinking through your logic, it's really helpful to think of it as true and false, because those are the only two states it can hold. Any questions at this point? Oops, let's not do that. Okay. I'm just going to comment this out for a second. And the next thing we're going to, actually I'm gonna leave that, because we're going to talk about constants. And what a constant is the variable that you can't change. So in C, how you would define that is you would use kind of like this pound include, you would use pound define. In C++, you don't use pound define, you use this keyword const. And I'm going to define it up here because it's normally where you're going to define your constants. So you're just going to say const, and then you're going to put your data type. I'm going to say int, and I'm going to call this, I'm going to call this num, well, const num. And then you're going to put the value equals 7. So if I go ahead and add this, we'll be able to print it. Yep, here's our 7. Okay, so that's how you declare and define all your variables. So now let's talk about how you actually change variables. So there's basic operators for this. If you're just going to set it equal to it, though, you're going to use kind of what we did right here. Just use a single equal sign. So right here, I'm going to get rid of a bunch of this stuff. I'm just going to leave my var just so we can mess with that. Okay, so right now we're going to print out my var. Now let's go ahead and change the value that's in my var. The way you do that is, of course, you're going to reference the variable by its name, and that is my var. And if I'm going to change the value, I'm just going to use a simple equal sign. And so right now my var is 0. Let's go ahead and change it to 5. And now if I go ahead and print it again, it should first print 0 because that's what it first is initialized to. And then right here we set equal to 5. So right here we should get a 5. Bada book, bada boom, that's what we have. Okay. So a lot of times when you're programming, you're going to want to change numbers in a little bit more interesting way. One of those is, of course, just doing basic math operations. And those are all pretty much going to be what you think they are, as far as what you're typing on the keyboard. So if I want to add something, let's just add basic numbers. Let's make my var equal 5 plus 5. So if I go back into here and recompile, we of course get a 10. And it's just that simple. If you want to add two numbers, make a plus sign. If you want to subtract it, guess what? It's a minus sign. You get 0. If you're going to multiply, there's the asterisk. The star kind of looks like the You probably see the dot and stuff in actual math class, so that's the asterisk, that's how you multiply. We compile 25. If you're going to divide, you're going to use, I think this is backslash, right? Or is this forward slash? This is backslash.
That's forward
Either
slash.
way. This is forward slash? Okay. Forward slash is divide. 5 divided by 5 is 1. Let's make a comment of that. Plus, minus, multiply, divide. Okay. So yeah, we can add that to we can do that to basic numbers. But that's not very useful because we could just type 25 or 10 or whatever. So one thing you can also do is you can actually do this to variables. So let's say I want to just add 5 to whatever is inside of my variable right now, my var. So what I do is I say my var equals my var plus 5. And then right now my var has 0. We're adding 5. So we should get a 0 and then a 5. So you can add a variable with actual numbers. If I were to come up here and define another int, let's set that equal to 8. I can add 2 variables. So my var equals my var plus another. My var is 0, another is 8. We add them together and set it equal to my var. We're going to get an 8. And if I were to come over here and make another uninitialized int, I can set thing, which doesn't have a value in it, and I can initialize it down here. Well, I should maybe print it. Yep. So right now what we just did, I'm going to explain this statement a little better, is right now thing doesn't have anything in it. That doesn't matter because we're just going to be setting equal to it. My var has a 0. So what it's doing is it's saying, okay, you have my var. I'm going to go up here and see what it is. That's a 0. I'm going to put 0. Okay, you have another. Let's go find another. Another is 8. Bring it down here. 0 plus 8. And we're going to put the result of that in thing. So then the result of that goes up here to thing. Okay, so thing is currently 0 or 8. Thing is currently 8. And we're going to print it. So it goes up here, figures out what 8 is, brings it back, prints it. Does that make sense? Any questions? Okay. I'm going to skip to that. Okay. So the next thing, I'm going to get rid of some of this stuff just because it's kind of confusing at this point. So you don't have to. If you want to leave it, you can go right ahead. Bring it back to our basic. So the next thing I'm going to talk about is comparing variables. This will tie in nicely to the thing we're going to talk directly after this. But for now, let's just talk about how you compare variables. And the first thing I'm going to tell you is, I'm going to tell you this right away, because if you're going to make a simple mistake, it's probably going to be this. If you want to see if a variable is equal to another variable, you're probably thinking, oh, it's an equal sign. But no, because we just use that to set something equal to something. So the single equal sign is not how you compare. What you're going to use, if you want to see if something is equal to something else, you're going to use a double equal sign, okay? The double equal sign means is equal to. So let's go back in here. We're going to make 2 variables again. I'm going to say int 1, and I'm going to set it equal to, actually probably should make it 1 first. That makes it not confusing. And we're going to make another one in second. And I'm going to set it equal to 3. So if I want to see if first is equal to second, I can say first equals second. So remember, when we printed the Boolean the first time, it printed a 1 and a 0. So right now we're comparing first and second. First and second are not equal. So if I run this, we should be getting, I guess we're getting errors. Why are we getting errors? Hold up.
I put them in parentheses.
That's it. Okay. Thanks, Rick. But yeah, so we got a 0 because they're not equal. So if I wanted to make them equal, I just set this equal to 9. Now when it comes back to try and compare them, it's going to give it a 1. So that's how you see if something is equal to it. So our first operator is equals equals. Our second operator, is if you want to see if something is not equal to something, this one's a little less intuitive. It's exclamation mark equals. The exclamation mark in a lot of programming languages just simply means not. So not equal. So if I go ahead and change this to a not equal, this is going to now be a 0 because they are equal. So for the second one, if you want to see if something is less than or greater than, it's literally the same as just math class. Less than sign, greater than sign. So let's make second a 0, and we're going to see if first is greater than second. And it is. Less than, same thing. If you want to see if it's less than or equal to, it is less than and the equals. Of course, greater than would then be greater than and the equals. So that's how you compare variables. You just have these 6 operators. And this is going to tie nicely to the next thing we're talking about, which is if statements. And for those of you in CSC 150, I'm told this is where you're currently at. So what an if statement is you're oftentimes in your code, you don't just want it to, have one function. You want to be able to actually, have it do something if something is true, basically. So the syntax for this, let's put the C out. So I only want it to print if something is true. And let's just give it a message. Okay, so the syntax for what is called an if statement is just if, parentheses, and then you're going to use these curly brackets, okay? I'm gonna put this in here. Okay. So the if statement, the if just basically says it's an if statement, and anything that's inside of these curly braces is only going to execute if the if statement is true. And the way that you determine or the way you actually put the conditions for the if statement or say what is true is it goes right inside of these parentheses. So now if we were to say our first is equal to second, right now if I set them equal to both so that they're the same, this should execute when I run it, which it does. So yeah, anything that you want to compare and you want to execute for your conditions, those go inside of your parentheses. And you can put if statements inside of if statements if you want. So I can just go ahead and say, if first is 9. And oops, that's what's supposed to happen. And then if I put this in here, Emma. Okay. So now this is only going to execute if first is equal to second and first is 9, which it is. So it says it's true. Now if I was going to change this to 8, it of course would not execute. But if I wanted just to show you guys how this is actually working, what it's doing is it's coming in here, it's testing first equal to second, which is true, okay? So this executes. So just to show that, I'm going to see out first if. So now when I run it, this is going to execute because this first part of the if statement is true. And it does. And so just like our main, the if statement is also going to just run from top to bottom. So what it does, it comes in here, compares, and then it's going to run any code that's inside of the curly braces. So it comes through, runs this. Now it hits this, okay? And it has to check again to see if first is equal to 8, which first is not equal to 8. So what it does is it just skips everything that's inside the curly braces and now comes back down to here. So if I see out another message and put an end L, so we're just all on the same line. This will execute, this will execute, this will not. Yep, first if, again. Now let's see, first is equal to 8. So let's make first equal to 8. Now nothing's going to happen because first is not equal to second. Or first is not equal to second. So what it's doing is it's going to come here, check, come down to here then because it's not, oops, I got to actually compile it because it's not true. Yep, no output. Perfect. Okay, so I'm just going to back this off. So we have just the if statement because the next thing I want to tell you, talk about is the if else statement. So sometimes you want to compare, like you want something to happen if this is true, you want something else to happen if this is true. And all that is you're just going to say else. Or actually, I misspoke. Block that out of your memory. The else statement is going to execute if the if statement is false. That's what the else is for. So it's basically saying if this is true, do this. Otherwise, if it's not true, do that. So all you're going to do is you're going to stick the word else on the bottom half of your if statement, and you're going to give it its own set of curly braces. And now, if this is false, the else is going to execute whatever is inside of these curly braces. So if I say C out, and I can say else. So right now, first does not actually equal second. So what it's going to do is it's going to come here, it's going to compare them, see that it's not true, it's going to see that there's an else, and then execute this. And if I run it, it's exactly what happens. We got our else. Does anybody have any questions? If you do have questions, please don't be shy. I remember how difficult it is to learn this stuff for the first time. I know right now this is kind of a very fast class, mostly because of the time we have. We only have 20 minutes left in today's session. So I am going a little bit fast. So please, if something doesn't make sense, stop me. I know what it's like to not understand this stuff. Okay. So now let's go back to the thing I was trying to tell you about before with the else. So you have your if, you have your else. What else you can do is you can have what is called an if else if. So if I want to add that, I'm going to say if, I'm going to say else if conditions. So now what it's basically doing is it's going to test this first thing, okay? And if the if is false, it's going to come down here, it's going to test the next thing, okay? And it's just going to keep doing that until eventually something is true. So if I make another else if, what it's going to do is it's going to see if this is true, which it's not. It's going to come down here and test this. If this is true, it'll execute what's inside of these curly braces, and then it's going to exit and come down here. So at the first true, it's going to execute what's inside those curly braces and then leave. And it's going to do that the whole way down. Of course, we still have our else, but if I were to get rid of it, then it would just return down to the bottom. The else still applies though, because if nothing is true, like none of these statements are true, it'll execute what's inside the else. So let's just do a basic if else if. So if first is equal to second, I'm going to print the first line. Now let's do the second thing. If, or else if first, let's say if first is greater than second. Let's execute that. So let's just see out else if. And let's actually put them in here so we have some output. Didn't get the other extraction. There we go. If, else if, and let's just say else. All right, so right now, first is 8, second is 9. So what it's going to do when this runs, it's going to come in here to the if. So if first is equal to second, it's not. So it just stops and it goes down to the next thing. So if first is greater than second, and I'm going to make it greater than just for the purpose of this. So if first is greater than second, it's going to print this. So first is greater than second. So if I go ahead and run this, we get else if. All right, so let's change this now. So let's say like our first is 8. What it's going to do is it's going to come here, see that it's not equal, see that it's not greater than, and it's going to execute the else, which it does. So you see how we can basically just create a bunch of different conditions where we want something else or something to execute. And you can just string these together. You can put ifs inside of this, else ifs, you know, just layer it as much as you want in order to create solutions to things. One thing I probably should, I think I mentioned this before, you don't need the else. You can simply, if you want, have an if, else, if. And so if neither conditions are true, it won't execute either of them. It's just going to return down to the bottom. So right now we don't have any output because both of these conditions are currently false. And then also just to restate this, because I know I've had people be confused about this before. Of course, if they are true, or if it's the first one is true, so if they're both the same, this very first if is true. What it does is executes what's inside these curly brackets and then leaves, doesn't do what's inside the else if. So right now they are the same, and our first condition is to check if they're equal to each other. We run it. Notice how it only prints the first if. It doesn't print the else if, because what it does is it goes through, takes the first true condition, executes it, and then leaves. All right, any questions about the if statements? If, else, if. All right, seeing none. Yeah. So next thing we're going to talk about is kind of like the if statement. I'm just going to get rid of this else if, and we're just going to look at this keep the if, because we can basically use most of it. And what I want to show you guys next is called the while loop. When I say while, I mean W-H-I-L-E. And what that's going to do is, so the if statement only did what's inside these curly brackets one time. The while statement is going to do what's inside these curly brackets as long as these conditions are true. And you notice the structure is literally the same. You just change the keyword from if to while, if to while. So right now, first is equal to seconds, which they are. What we're going to get is a bunch. Oh, I hit the wrong button. I actually compiled it and ran it. Yep, it's just infinitely printing. It's just infinitely printing because there's nothing stopping it. Well, that's not very helpful. So let's do something a little bit better. I'm going to get rid of this first variable. And what we're going to do is we're going to see while first is less than 10. So let's set first equal to 0. And we're also going to print the value just so we can see it. Okay, so right now, while first is less than 10. We're still going to get an infinite loop because first is less than 10 and there's nothing changing it. If I run it, we get the infinite loop again. So let's actually go ahead and change it. So let's say, let's change it. Let's increment it one time. So let's add 1 to it every single time this executes. So first, we're just going to say equals first plus 1. Now, if I run this, you see we actually get a half decent output that makes sense. So it printed all the way from 0 to 9, 0 because that's the first value, and 9 because once this hit 10, so you know that's first equals first plus 1. First became 10. It came up here, compared first to 10, saw that it was equal to 10 and not less, and then exited and quit. So like now if I were to say less than or equal to 10, less than or equal to 10, build and run it again, now we'll actually get a 10 because it executed until it was equal. So the while statement, very simple, same syntax as the if. Again, you can put while statements inside of while statements. So actually, if I was going to copy this, and let's put this inside of here, just oops. What it's going to do is it'll actually do this and then do this again. Do this, because it's just going to loop. So it'll come in here, say while first is less than 10, print this, add 1. And it'll just do the same thing. So we're going to get a fairly interesting output here. Oh, actually, take that back. I guess because first is always. So let's create a second variable. So now let's compare second, while second is less than or equal to 10. So this will execute the first time because second is going to be less than or equal to 10. Oh, would you look at that? I've created an infinite loop. So you have to be careful with these things. There's so many times if you take a programming class that you think you have your statements correct, that it makes sense, and you're just going to start it and you're going to get like an infinite loop where it never ends because this condition is always going to be true. So, but you get the idea. If this were a good while statement instead of a while statement, it would eventually stop because that would be useful. But yeah, so the while statement. Actually, I should probably ask if I actually can erase these things. Does anybody want to write this down that hasn't yet? Get rid of this just because it's a little bit confusing. Going once, going twice. All right. So next thing I want, see here, 10 minutes. Yeah, I can start it. Okay. The next thing I want to show you guys is functions. And what a function is it's basically a piece of code that you can put anything in that can be run with a single what's called a call. And this will make sense in a little bit. So let's say you're programming. Let's see here, what would be a good example? You're programming a video game, okay, and you want your character to take one step forward, and you want it to take 10 steps, but there's a whole bunch of code to take a step, and you don't want to have to write that 10 different times. That'd be very impractical. The way you define a function is you don't actually put a function inside of your main. We're going to put it down here, okay? And so the syntax for a function is the very first thing you're going to put is the data type. Functions also have data types, the same data types as variables, but it also has another data type called void. And all void means is I don't actually give off any information. I just run. That's all. So the first thing we're going to make is a void function. So void, and just like, so the data type, we're going to give it a name. Just like our variable, we're going to give our function a name. So let's call this my function. And we're going to put parentheses. Now, unlike the if statement and the while statement, this is not for comparing stuff. This is actually for giving the function information. And I'll get to that in a second, but for now, just put the empty parentheses. You can leave them empty if you don't want to give it any information. And then the last thing you're going to do is you're going to give it your curly braces, because the function is, of course, just like main, going to run from top to bottom and then exit. So let's just give it a simple cout, and I'm going to cout okay. So that's the function. Very simple function. Now, if I want to call this function, what I do is I just reference its name. So my function, semicolon, this is the statement. So my function, semicolon. So what it's going to do, your main is going to start up. It's going to see, oh, so you have a function called my function, and it's going to go down here. It's going to see what's inside of my function, and it's going to execute that from top to bottom. Right now, we only have the one statement. But right now, if I run this, we're going to get the output. Why? Oh, you need those. You need the, because if you're going to pass information, you need the parentheses. But what on earth? Why are you mad? Oh, I'm too much of a Java programmer. That's why. Okay. So those of you in the C class are probably screaming at me right now because you're like, Joel, you didn't make a prototype. You're right. I forgot to make a prototype. And all a prototype is because we make our function down here, it doesn't actually know what it is because your entire program actually executes from top to bottom. So what we have to do is make what's called a function prototype. We literally just take the first part of this function, put it above our main. Actually, we're going to put it above our constant just in case it uses it. So we're going to put it above our constant. Void, put basically what's that first line, and then it with a semicolon. And now this will finally execute, now that I've remembered the prototype. So you're making a function, data type, name, parentheses for information. I'll get to that in a second. Curly braces, and anything you want to execute. So if I put another line in here, it's going to execute this and then this. If I gotta close that. Boom, boom. Perfect. Okay. And I can call this as many times as I want. So if and I'm not getting autocomplete, it's kind of annoying. If I come in here and I type it again, it's going to do this, come down here, print this, and it's going to come right back here. And it's going to execute the next line, which is, again, a function. So it's going to come out here, do this, and go down here, and then exit. So we should get this twice. Stuff again, and I didn't end line it between it, so we get the same line, stuff again. Maybe just help you see that like a little bit better what's going on. There. Now it's different lines. But yeah, you'll see how and you can do anything you can do in here, you can do in here. Functions are basically just a way for you to break up your code into manageable pieces that you want to call like over and over again. So yeah. So now let's finally get into what's these mysterious curly braces or these mysterious parentheses. I've got 5 minutes, but that's not an adequate amount of time. So right now, if I were to make an int variable, and I tried to print this right now. I don't think it's gonna compile. If it doesn't compile, it won't run. Yeah, you see it's mad. Because what we need to talk about right now is something called scope. Now, these curly braces partially define scope, okay? This int right now can only be seen by the function main. So it can only be used by all of this code. It can't be seen by this right now. So if I want to use a variable inside of a function that is not inside the function, I have to pass it in. And the way you pass it in is you're just going to create basically I want to call it a fake variable. It's called a parameter. And the syntax is literally the same as if you're going to define a variable, but you're never going to give it a value because you're always going to be passing it. So let's call this int parameter. So now I'm going to call this parameter. And now if I come over to my function and I pass it var, now we'll actually be able to print out what's inside of var. Because what it does, you know, it comes down to this, my function. It's going to see, oh, I got to change up here too, because prototype has to be the same. So this executes, comes down here, sees you want to run this function, sees that you have an argument that's, oh, it's an int called parameter. It's going to put var down into here. And now we're finally actually getting it inside. It has the name parameter, but it only has the name parameter inside of this function. And I can do this with anything. So like if I make another int thing, give it a 9, I can pass thing. So you can pass like anything you want as long as it's the correct data type into this. So if I run this finally, 9 or 10 again, 9 again, with our two function calls that we're passing different information into. And you can pass as many pieces of information as you want. So let's get off of the ends. Let's make a string. I'm gonna call it string message. And just for simplicity's sake, I'm just gonna put this. I'm not actually gonna make a variable for it. Yeah. And of course, because I changed it down there, I gotta change it up here on my row type. What did I do? Oh, yeah. Don't want a semicolon there. There we go. Oh, might actually help if I print the message instead of just random stuff. Yep, so that works just fine. I can also I can just create a variable in here if I want to, without passing it in. So if I make an int variable, you notice none of these are being used. It'll just warn you. It won't actually complain. But now it'll print a 10 because I've now made a variable inside of my function. But if I try to access variable up here, so if I try to see out variable, again, it's not going to do it because it's not within the scope of my main. Yep. So you maybe have noticed by now, main is actually a function. But the thing about main is that your C++ compiler recognizes it as the function that is supposed to run first thing when the code starts up. So. All right, so that's all the time we have. Does anybody have any questions before we wrap this up? All right, I'll stick around if you want to ask some questions. Otherwise, yeah, thanks for coming, guys.
Thanks, Joel.